we sort of have a mixed way of doing this, and I think what we'll do is just start and let's see. Let's start on this end with Joe. Would you take a few minutes and just describe how you're involved?
Sure.
And then we'll work our way down the line.
Great. So I'm Joe Jankosky. I'm a director with the Intel Energy Center of Excellence here in Austin. I joined Intel from Southern California Edison. And so I work mostly on grid modernization. Intel, I think everybody knows what Intel does. I will say that we don't make sensors, but we do make the processors into which all the data from the sensors and the networks and the gateways that are in between, where all that data is crunched. I think the relevant part about where Intel is focused is on the electrical substation, where transmission voltage comes in and is stepped down to distribution voltage. If somebody doesn't know what those are those block long series of transformers where big electric lines come in and smaller ones come out. An easy way to say that. And traditionally, those substations and the equipment in there have been monopolized by 5 big OEM manufacturers like GE and Siemens and Schneider Electric and Schweitzer and ABB. And the utilities that we work with, and I think all utilities are stuck in this sort of vendor lock, where if you have 5 big companies controlling this space, there's not much incentive to change. And so the substation technology has not really evolved as quickly as other industries. So in the telecom industry 20 years ago, all of those proprietary fixed function devices were disrupted, and all of the data from those different workloads on those fixed function devices was aggregated into servers. And servers from the big server manufacturers like Dell and HP and Lenovo. And we're seeing that same transformation take place in the electric utility industry. The substation is the most important part to disrupt. That is where all the DERs, wind and solar and storage and so forth, interconnect. It's where all the local decision making needs to happen in real time. And so that's where Intel places its focus. And we're really bringing more processing power to the edge, and taking all the data from all those wonderful sensors, and more to be supplied will proliferate through the industry. And what we hope to bring is a non-proprietary, software-defined architecture to the substation and transform the grid. We can take more, the most important part is we can take more DERs into the grid and reflect positive changes in global warming and climate change. But it also makes the grid more resilient, less outages, and actually more reactive in real time to reactive disturbances. So I hope that wasn't too long.
No, that's
got a few minutes in there. Didn't plug Intel too much, but
I was going to say one question. It's called the Center of Excellence. Why?
Well, because our president wanted them to be called Centers of Excellence. We have about a dozen Centers of Excellence within Intel, and they're really, the computer chips are horizontal by nature. They're meant to go everywhere into every kind of industry. But there are about 12 specific industries where Intel wanted to hire experts from outside the semiconductor industry, like myself. I don't know a whole lot about semiconductors, and been at Intel 7 years. But I mainly stick with getting the voice of our utility customers and bringing that into Intel and creating solutions for them.
Thank you. Thank you. Jerry?
Well, Giri, Iyer, my function is business development, so I focus on regulatory oversight, kind of watching what is happening with the infrastructure bill, and all of us are anxiously waiting for the GRIP funds to be released. Hopefully soon here, Andres, make a phone call. And then you just heard about Sentient Energy. We focus on distribution grid analytics.
Okay. Eric?
Yeah, my name's Eric Sondhi. I work in ARM in our IoT line of business. I've been at ARM for about 7 years. And my focus at ARM, I'm a senior manager in our IoT line of business over the last year or so, but most of my tenure at ARM, I've been looking at enabling developers, SoC designers that take ARM's architecture and couple that with a range of tools that range from compilers to models for building virtual platforms and other design tools to help them innovate, get a shorter time to market, bring up software on their silicon faster, and also over the last couple of years in particular, been looking further down the value chain than just semiconductor vendors to actually enabling OEMs and the broader industry at large to develop software on ARM earlier, more ubiquitously, and basically solve some developer problems that are barriers to adoption, not of ARM's technology, but barriers to adoption of ubiquitous intelligence, AI, connectivity, all of the complexity that you see in modern IoT devices. There's just a range of complexity that's coming together that's ultra low power, and more ubiquitous. And so there's a large range of developer problems for adopting these devices, bringing them into cloud native workflows if you're making services, or scaling your really traditional embedded workflows if you're on the device side. So over the last year in the IoT line of business, I've been focusing on several different segments, industrial segments, and utilities being one of them, to help bring the best practices for designing SoCs to new semiconductor providers, so new startups developing and innovating technology, as well as some of the bigger traditional OEMs, but also bringing our virtual prototyping capabilities more at scale to software developers earlier in the life cycle, so that you can get software up and running cloud natively. You can build products and have cloud native software that will run on these devices more connected and more easily able to adopt AI algorithms that are developed and trained in the cloud and migrated over to edge devices, and just really helping break down some of the barriers to enable scale in multiple segments.
Victor?
So I'm Victor Carr. I'm the person, so I can wrap all of this up into one entity, and that was Pecan Street when it kind of came to its inception. So it was doing a lot of those things in a local area inside of Austin, and we were getting all of these vendors in to do such. So I was brought in from Austin Energy, and I came up with a use case to try to tie a lot of these things together into something that we could say we can champion for Pecan Street. And of course, Pecan Street does so many different things. I'll just tell you about my use case, and you can kind of understand how it kind of dovetails into other things. So my use case was we could have IoT sensors on top of pulse wave sensors that would say, anytime a vehicle hit it, it had a certain signature to say that a vehicle hit that pole. Well, with that information, you could send it to the control room to say that, hey, a pole's been hit. You could also send it to 911 to say that you may need to send somebody. Then you could use autonomous vehicles. You can actually dispatch an autonomous vehicle to that site in case that person is hurt. You can dispatch a drone as well so that video information can go to any entity that needed it. You could also dispatch that information to hospitals and clinics to see who had the lowest triage to tell you who that autonomous vehicle could go to at that time. So that person can get information as well as help before the first officer or fire person got there. So those kind of things got people thinking about those different pillars and saying, okay, how can we make that type of thing happen in the near future? That was a long time ago. That still hadn't happened. So that's my involvement with Pecan Street. So I might have a bunch of interesting anecdotes about what my life with Pecan Street was.
Thank you. Today has been interesting in the fact that we've had both the industry side and the personal side. And so what I'm actually doing is, and the panel's hearing this for the first time, we're going to actually go through a series of 5 questions, once from the industry side and once from how it affects the people. And so the first question is really, what are your opinion for the sensors that will improve customers' reaction and acceptance? Victor?
Okay, cool. Being the first time I heard that question. I think certain sensors like those pole top sensors, what if we had environmental sensors that would make it to where, let's say that you had a certain issue with a certain pollen and you wanted to go to the grocery store and you had something to tell you, hey, in this general area, you didn't have any of those types of pollens. That would be the grocery store you would go to. So that would actually change that customer's action based on the data that they got from an IoT device.
Okay, I would higher the higher level. We'll do the customer. We'll just start it at the customer, the end user.
Okay.
So Eric, any thoughts?
Yeah, so it's when you think of sensors, it's just such a broad range of sensors that come together in different ways, whether it's pressure or CO2 detection, and it depends who the customer is, right? So if you're in your home and detecting the efficiency of your home HVAC system, right? You'll measure CO2 concentration with the combination of sensors, and it'll be ubiquitous.
What do you do with it?
Well, you decide whether you make an upgrade and overhaul your HVAC system, and maybe you make a decision based on how efficient your system currently is to lock and insulate your home better and move the heat pumps, for example. Right? So there's a really end consumer question that gets raised as these sensors are ubiquitously used to measure efficiency at the individual consumer level. But it also, I think, for the industry level, I think it's also how do you bring about and scale detecting energy efficiency and things like that.
We'll get back to that in a little bit.
Sure.
Yeah, I think I'm going to build on Victor's use case with a different one. So let's take the case of wildfire. For example, something that became mainstream here in the United States, unfortunately, around 5 years ago with California. To give credit to organizations like PG&E, they decided to do something very dramatic. And when they couldn't see what was going on because of these high winds in areas which are difficult to reach, but still dangerous, they actually decided to shut down power. They called it PSPS, which was version 1. Version 2 was basically now using intelligent devices, sensing control devices together to say it is safe to start restoring power back in those areas. And here is where I'll bring companies like Sentient Energy into the table, where you saw what we were showing in terms of reliability. The exact same data can now go and help them and basically now mitigate how much area is actually losing power. That's the use case that we're able to provide them. So it takes their program, which is safety first, safety second, safety third, and then once you're sure, bring back the power, right? That is what a wildfire has meant for folks, is now we can actually help them target a smaller region that is going to be disrupted, because even those who are going to be disrupted are going to be definitely inconvenienced that they lost power, but you rather be safe because now there won't be vegetation hitting the power line and that triggers a wildfire. So that is the way technology can help that particular use case. And the benefit for consumers, really coming back to your question, Walt, is that the utilities are constantly thinking and designing superior grid resiliency systems. I know that helps.
Okay.
No, that's a great example, the PG&E. I've spent some time with them as well. And it takes a more surgical approach to they call rolling blackouts or
Exactly.
in the case of there not being enough energy to supply everyone. I think that sensors are going to be installed everywhere. They're going to be ubiquitous. Putting them on the electric grid is somewhat new, I think. As your business might attest to, and just because it's still operating as it did 100 years ago, and that's somebody brought up on the earlier speaker, the earlier session, that was where the person was not in person, about policy changes, and that's particularly difficult in the utility industry. These organizations are slow to change; they're heavily regulated. you pay a severe penalty for getting anything wrong, for the lights going out. And so they will, if it's something new and has at least a little bit of risk associated with it, they're more likely than not to not take it on. And so I got to applaud you for your company making the kind of inroads that you have. In the opposite direction, I mean, you have to be somewhat judicious about where you're placing sensors. I bought an electric razor the other day that it could have been Wi-Fi connected back to Philips. I didn't necessarily want to do that. I think that's absurd. But some people might. Who knows? But the old one about connecting your electric toothbrush to the grid. So.
You probably got the most experience shifting gears.
Yeah.
What's the reluctance going into somebody trying to tell them what they need? What kind of pushback do you get? This is you're going in and you're saying you really need this. And I mean, you showed us some examples.
Yes, sir.
But what kind of pushback did you get and how hard was it to make this happen?
Yeah, no, look, I think the pushback is not because we have to remember utility folks are mostly engineers and they're, anything but, shy. The ramification of knowing something before it happens puts a very heavy burden on the people who manage the grid. Then you're immediately liable to do something about it. And the choice not to do something, therefore, has other consequences, unintended consequences, just like you articulated, right, Joe? Mm-hmm. So I think that's one of the pushbacks is utilities are beginning to grow in confidence with AI, but the main pushback is how will my customers respond? Is this safe for me to do on my grid? And then how do those who regulate us respond to this kind of investment from us?
Well, okay, but if you go to the personal level, you want me to buy this, and if I'm wrong, what's it do to my job? So how do you convince me, I'm with the company you're trying to sell it to. You're saying it works, and I'm saying, yeah, but if it doesn't, I'm meat.
Oh, well, I can dispel that myth in a heartbeat. The fact of the matter is there's so much work, and I think I asked that question to Rick and Greg earlier this afternoon, right? There is so much work to go around utilities, and there is so many jobs in the utilities. This is only going to give some breathing room to the Victors and the Sterlings of this world to basically do a little bit, smarter work. I mean, otherwise, literally running from, no pun intended, fire to fire.
Right. Okay.
So I do not agree with the premise that this is going to somehow take away jobs. This is actually going to give more room and more time for utility folks to do the right thing and then create new jobs which require different skills. Right.
Looks like you've got it.
Well, I was going to say the utility process for trying new technology is it's going to go into a lab. It's going to be studied. Then maybe if you're lucky enough after a couple of years, it'll go into a pilot. And I'm not being, entirely pessimistic here, but this is what we've seen. And then, from a pilot, in order to get something at a utility scaled, you have to put it into a rate case so it gets paid for. So that's a once every 3 year circumstance. So you're really in this for the long game. If you can make a service maybe and offer that service that doesn't disrupt current operations, but maybe it runs in tandem without disrupting what's currently driving the system, and you just are along for the ride to show how you can better the situation of that particular engineer. I think that's a great way to go.
Yeah, I think that's spot on. I think you were talking earlier about a paradigm shift. So how can you get infrastructure and utility companies to proactively adopt a paradigm shift? It's finding the right windows of time where they can take a pilot project and bring in effectively a new methodology, new hardware, new infrastructure. And what we try and do is play that long game and, for new hardware architecture, new designs and new capabilities, whether AI or connectivity, provide technology and methodology early for products that are not there today necessarily, but products that will be built 5 years from now at scale, so that the software developers, the people that provide software into that value chain will have the tools they need, and they will actually have the methodology in place such that as the products start to show up on market, they can adopt them and intercept these windows of time where the few that you have to just start to make these paradigm shift types of changes that are really a long game.
And you got to find a champion.
100%.
In hidebound industries like electric utilities, let's just say conservative industries, most people are going to toe the line. There's always going to be a wildcat thinker out there, and you just got to find that person, and that person can hopefully drive you into the rest of the organization. But I always find that there's always one person who says, "Yeah, I want to disrupt this place," and you got to connect.
Okay. Victor?
I'm that guy.
I was just going to say, if he wouldn't mind, I would say that Victor is the guy.
Yeah, I am that person that does that. I think when you say paradigm shift, you got to be careful with that because utilities, anything's a paradigm shift. But then you have investor owned, and then you have municipalities. Yeah. So those are two different things. You're absolutely right on municipalities. That's how that works. But investor owned, you have already, you have different departments that actually handle those type of things, and they can ingest those a whole lot faster. And if it affects the bottom line, it's going to happen a whole lot faster. That doesn't happen that way in municipalities. Municipalities, it may have to go through several, policy situations before you can even get to speak to the right person. So it's always good to have that person in any utility or any company, period, that can actually see something and to see how it benefits the company and be able to bring it in, like I would in any situation.
One comment, Walt, I may add, which I think is a positive tailwind to the industry. I'm going to humbly submit to you that when the first round of funding came in 2009 to 2013, the utility industry was a nice, quiet place. I mean, typically load was growing only yay so much and so on. Something's happened in the last few years. The climate change, the EVs and the solar.
Lots of cars.
There's a lot of attention on the grid. So I'm going to suggest that we are seeing the democratization of the grid happening in a very big way. Consumers are beginning to ask a lot more. The reliability metric used to be, 5-minute outage is okay. But now, if my daughter can't get her phone charged in 3 seconds, she's going to stop breathing. So it's a life critical event. Right.
Okay. What about security? I think we'll start with you.
Yeah, security is one of those things you just expect, especially at the consumer level, but you don't necessarily want to pay for or invest in upfront at the buyer and customer level. You just expect it to be there, and it is essential. It's everything is connected fundamentally nowadays, and now also with AI, there's things are trained on data sets that are that need to be protected as well, right? And oftentimes there's some level of protection that is on the inbound side and also on the consumption of data side. So it's a paramount aspect at both hardware level and software level, and there's many different approaches. What from a pure architecture side, I'm sure Joe can also relate. You want to kind of do your best to standardize and design with security at the onset, right? So it's an engineering discipline that's there at the hardware level, and also the instruction set level, the software that will be developed on your computer architecture needs to be secure at the onset. So and at ARM, it's a very big focus that actually is part of our instruction set architecture. Security features and capabilities are there built in.
Okay. Victor?
It's one thing when you say security.
With security from the company level.
From the IoT standpoint,
Right.
You realize you want every device to talk to every device. But at the same time, you don't want every device to talk to every device. So when you say security,
That's the question.
what are you really trying to get to? Because you need to know what session is happening at every single moment. And that's going to be very difficult to do. You know what things are supposed to do. You know what architecture is set up for it, but that architecture doesn't match your internal security structure of your day-to-day networking of your company. So you kind of have to have two kind of frames of thoughts. You can't kind of combine it to your current business practices because it just doesn't work that way. You have to have a whole other set of thinking for security for your IoT structure that you do your business structure.
So basically, the companies have to evolve.
Yes.
We take security very seriously. All of our devices, especially for the data in motion, are fully encrypted. And then the data, and then we also go through a very elaborate SOC 2 compliance process to make sure we're doing everything we can from our side to reassure our utility customers that we are a good, solid partner who's made the investments necessary. The burden on them, though, never goes away, right? Because I think they are looking for a set of trusted devices and a set of trusted processes that they know can operate with their eyes closed. And for you to earn the right to be one of those is a hard hill to climb. And I expect Victor to beat me up for a while before he finally says, "I'm good, we'll deploy it."
Okay.
Right. So it's a right you have to earn because, and I'll just put in a plug for the industry again. This is the mother of all industries. The grid goes down.
True.
Yeah.
Sure.
So I don't blame them for doing what they have to do.
Okay. Slight difference on the question. How do you evaluate the different security measures that could go on? Since Intel is quite involved in security. I've got a new type of algorithm. Okay.
Mhm.
I come to you, what do you do with it? How do you check it out? From the industry standpoint.
Yeah, I'm not sure how to answer that. I was going to come up with a different tack on security, but maybe this will give you. Maybe this will address it. What you're asking tangentially. That people think that if something is not connected to networks, that it's safe, right? And if it's some sort of analog system, and if it's some black box that's not connected to anything else, well, yeah, it's safe, but you can't do much with it. And then they go into, well, we'd like to digitize this, but we don't want to open it up to any form of messing with what's already there. Well, then you can't take any software patches. Right? Think if we all had an iPhone that you never had any updates to, you'd have so many viruses on your cell phone. It wouldn't even it would astound you. So that's what you have to have. You think that the more you lock down your box, the more secure it's going to be, but that's not always the case. The more you're able to keep up with the current technology, if something comes out and it's starting to infect the system, you can shut it down. I think that you have to sort of embrace that rather than being, a Luddite and just saying, no, I'm just going to stay in my little walled garden here. I don't think the world is progressing that way. I think that we have to have more of a mindset on security, but take it into a more active phase as opposed to let's put some walls up.
Okay. Then the question, and I'll start with you again. How much data should be collected?
Well, that's a good question. You can collect an infinite amount of data. The question is not how much do you collect, it's a question of where do you collect it and what do you move on to the next point. So you're talking from the edge to the cloud. Does every piece of data you need to have that you find on some sensor need to go to the cloud? Not at all, right? So you're having all this data come in and it gets consolidated, and then the learnings from that data get communicated up to the next level. Maybe that goes to an enterprise data center. And then the learnings there maybe go up to the cloud to be crunched or analyzed with other reference packages. And that gets pushed down, but it doesn't get pushed down all the way to the edge because the edge doesn't need all that. The edge just needs a specific information. Tell me what to do now with this sensor. So it's really a question of how do you move that data around? How do you consolidate it? We always say, you want the data that needs to be at the place to make the decision. No more, no less.
You can talk about visualization, which makes it easier
We can, but I think what the question perked in my mind is a healthcare example. And Daryl and I had a healthcare event here this morning, so I can tell you that sometimes in healthcare they use the word comorbidities, which is, oh, I'm giving you a medicine for this, but one of the side effects and unintended consequences is something else, right? So I wanted to bring back that question of the algorithm that you asked him, and basically say, utilities, those have the enterprise systems are running a few major algorithms: state estimation, load forecasting, power flow analysis, optimal feeder reconfiguration, those kind of programs they're running. When you bring in a new algorithm in that, we have to remember it's a system of systems, right? It's a system of systems. So they have to make sure the overall state is managed for stability, for reliability. So that's why any algorithm, before it is accepted, goes through a rigorous set of testing, because you don't want to set up that unintended consequence which you were trying to avoid in the first place. So that would be my answer: is you need a lot more automated software testing and a lot more AI functions to run in the background with IoT.
Okay, I'm gonna leave you for last, Victor.
Oh man, I got used to it. I would say it would be astonishing if you would find out how many, no AWS people in here, right? How you would find out if you had every meter, every device communicate to AWS, those transaction fees would be through the roof. So there's no way you'd want to store anything up there. You want to store as much on premise or on the edge as possible, and make your transaction things the things that you actually use for transactions to the cloud. That's how I would say.
What I actually heard here is that in between the data and getting to the cloud, there's a number of processors that are doing reduction. And
Yeah, the blocking and tackling of the data processing that Joe outlined at the start of this is essential, right? So and this is true for machine learning, like, so you don't need to send everything up to a neural network in the cloud. It actually wants sometimes a ultra-low power device to do the word detection right there, or something at the edge. And that's not just for the cost aspect, because it's a functional and user experience aspect as well. So balancing where you process data is essential. And then also, there's also the lifecycle management part of data as well. You don't want to keep all the data around forever. Data is already exploding, and the footprint for storage is exploding anyway. So you have to be able to use the data, consume it, turn your metrics into analytics, move on, discard the data after. There's also a privacy aspect to where the more data you keep around, the more susceptible you are to the security issues we started to hint at earlier, and then also exposing private data. So,
Walt, if I may put in a plug for two things, and Daryl is sitting there in the back. There are two things his team does really well, which is important, right? Knowing the cost of moving the data from a device at the edge to the cloud, you have to use the very best compression technologies that you have, number one. Number two, success for us is basically making sure that in the end, when we have proven an algorithm, he has a firmware team. And their job is then to execute the algorithm right at the edge. So you don't need unnecessary raw data moving back into the cloud. So I think for us, that closed loop where our sensors are becoming smarter, they're not static devices, they actually have brains that are actually learning as they go, is part of that closed loop system that I think companies like us want to build.
Okay. Now I want to shift gears. One of the areas that I'm interested in is how do we serve the unserved 10%? Or if you look at it the other way, and also the elderly population. And with that, how do you tell them something? How do you get them to accept what you're going to do? And start with you, Eric.
Yeah, it's a good question. I mean, I think technology moves pretty fast to begin with, and it can be overwhelming, and sometimes it's pushed upon you. But I think the best way is to educate people and relate to their problems, right? To relate to the problem that you have. And I'm from Massachusetts. We have a GreenWorks program where the grid comes to your home and does home energy assessments, which are incredibly invaluable for educating you on. And it's a bi-directional communication. The customer talks about their problem that they're trying to solve. Maybe they're not happy with the one zone that they have for air conditioning their home, and they need to change it. but the people that are experts on, maximizing efficiency in your home come and tell you and educate you on the latest technology and what might fit, what might work. So I think that's a really important step to reaching the last 10% or populations that are less might just have less exposure to all of the technology and the buzzwords, but related to the problems that are meaningful to actually move their personal bottom line and up.
Okay. Joe?
Well, if you look at the grid, and again, I'm going to come back to the grid. I mean, much of the infrastructure is often placed in low income areas, and that's for a reason. That's a political reason. I mean, it's for politics. I mean, you're going to put them in low income areas because people in high income areas are going to complain about it, and they have more legislative power. I think that when we think about democratizing the grid, we want to be careful about where we place the infrastructure, but we also want to give benefits back to, I think you called it the 10%. So when you think about EV charging, you have public EV charging, but you don't have a lot of it in low income areas. And that's something where we want to focus on, and Intel tries to provide services to those EV charging manufacturers, and through our sort of policy representation, affect change so that you can get an equitable distribution of not only renewables but also electric vehicles, and to take advantage of the grid is changing, and how do you change it to benefit all parties?
Giri?
I think I'm going to take your 10% number and raise it a little bit.
Okay.
If you don't mind. There are 2,800 public power unis and co-ops in this country. I'm going to say the level of automation probably could use a lot of help, about 50% of them right now. Right. So Sentient Energy, the way we look at this is we are marketing the idea of a fast time to value. There is this perception in the industry that every solution takes years to deploy, if not decades to deploy.
Okay.
Right. We think the average 5,000 meter utility can be live on all the circuits of their system in 3 business days. With our solution, no need for de-energization. And that adds the first situational awareness layer. It is that design elegance, that speed of implementation, and that compatibility with anything and everything that they have. We think that fast time to value is critical to solving the problems of whether they are the 10% or the 50%. It's the minimum viable product notion, if you will.
Okay.
Yeah.
Victor?
Are we saying we're getting them the data or the capability?
What we're saying is what are we giving them? How do they accept it type thing?
So from Austin Energy has one of the greatest customer assistance programs in the nation. It's been award winning and things of that nature. They pass a lot of data through that program to that 10% or probably more in these cases on a constant basis because they can't, for whatever reason, afford to pay the bill. There may be some reasons for that, and we help them with each one of those reasons, as well as pass whatever data we need them to know as well. And they are in some of those areas where land is cheaper. So you can put a substation in this area at a cost that would be different than putting it in a more affluent
Urban area.
So those are kind of the reasons why I see that happening a little bit more. And I see it happening more in the future as more people take advantage of that program, still being able to get them that type of data.
Okay. But some of the work and proposals I've done working with the Housing Authority, City of Austin, who has 1,800 homes of the low income. Right. And that during COVID, the problem was just getting communication.
Yes.
But we're going to do one last question, and we're going to start with you, Victor. If you could add something sensor to the people's homes, what would you add?
Can I do this?
You're going to do it
Instead
anyway.
of adding a sensor, add the capability of actually reaching multiple sensors by having some type of device in the house, may it be a panel of some sort to where you can actually control your consumption of your electricity or your water or whatever the utility may be, put that more in the consumer's hand than the general, businesses, the general business model that we have right now.
Okay.
Yeah, I was actually going to say something very similar, but I think it's a precursor. The actually control the consumption is wonderful. I was even thinking one step before that, the ability to just simply monitor and see what devices are consuming what. And there are these wonderful products that are there that you can install, but just making those standard issues, right? Just making sure they're in every home so people can actually have visibility into which device is leaking the most product.
The other thing too is if you have a typical home, you don't need a nightlight because you have all of the ghost chargers there with the blue lights and everything else. So
less nightlights.
Well, you don't need one. You get
less lights.
I can't add anything more to that. I think it's a connected set of sensors already in place.
So
Yeah, the technology is there. I mean, 10 years ago, I was giving away free Nest thermostats at Southern California Edison, and you couldn't give them away.
I can tell you why. I can't touch the thermostat in my house. It's harmful for my health. My wife will kill me.
So I think that getting people to care, the average individual to just care about their electricity usage is difficult. I mean, unless you're having a problem paying your electric bill, most people don't think about it. So to me, that if you could come out with some kind of easy system where somebody said, hey, let me just save you the most amount of money on electricity as you can within the comfort requirements that you have, and just sort of set it and forget it. Because people don't want to be checking their electricity usage on their Apple Watch. It's just, they got enough things to check. Maybe you would, but you might be interested. But sort of a set it and forget it approach, or just start charging the average home demand charges. Exactly. That's going to be tough, but works for industry and commercial. So,
okay. I'll open the floor to questions. Any questions? No questions.
Can anybody of you speak about the integration of my home, my car, my office files, my cloud? Is that like where it needs to be, or do you guys see that accelerating sort of the smart city, the smart home, the smart utility all colliding, collaborating? Where is that happening? Is it happening? Do you guys see it?
Who wants to take it?
I can start. I mean, I think I do see it happening. Like one example is with something called Matter, the Matter project from the CSA, Connectivity and Standard Alliance, which has a vision and a roadmap that goes from smart home and broader to smart city and smart industry. And I think it does start at some of the basics within the home, like your devices need to be able to connect on the network and play together and be ubiquitous instead of warring and having 10 different IoT device management technologies just to fund your basic functionality. But once you solve that problem at the home level and every home has it solved, then you're actually already at a smart city and level of scale, and it just evolves from there. And the car being software defined is an IoT device at the end of the day now too. So I think these things all do come together, and there's standardization in the industry. The biggest players in the industry have agreed to standardize and solve this problem for the greater good of advancing technology beyond the home into the smart city and smart industry.
I think it's happening because I drive a Palisade and Blue Link automatically has all of these things already set for it. And I also have an Alexa home. I have a Google Chromecast home as well. So all of these things are already working together. I can tell Alexa when I want to be awakened. I can tell her when I'm getting ready to, leave the house. So she'll start the car and have it ready for me. and have whatever temperature I want set already. And I can do that now. So at some point, I mean, even the way the new Palisades are going, the car will be able to take me to work. So I can just go to sleep in the car and wake up when I get to work and just plug it in. But but those things are actually happening right now. My lights, my dryer in the future, because it'll tell me when my clothes are dry. And now I need to just get one of those robots to go and get my clothes out and fold them for me. But those things seem like they're really right there because the pathways and the evolution is there already.
But people need to get to the simplicity on the other side of a lot of this complexity.
From the consumer part, it kind of looks like it is. I mean, once you set the skill in Alexa, it happens. You don't have to be a rocket scientist anymore. I mean, I remember when I used to have to do this stuff, manually, and you don't have to do any of that stuff anymore. I mean, I don't have to turn my PS5 on anymore.
I
It
think
comes on by itself.
part of the comment though is if there's a portion of the population that doesn't like electronics.
Oh, well.
Yeah, okay. And that's part of that 10%. It's like, oh, I don't trust, getting things straight to the bank. I don't like getting that electronics. Or how many times, could you help me get this phone working right?
They have a flip phone. Got it.
No, well, a flip phone, so in fact, yes, I know somebody just got a new flip phone.
Can I get you guys see it happening? Is this happening, Joe?
I'll give you a couple of examples. Ford and two other companies, I can't remember, competitors. I guess Ford and Toyota and one of the European, maybe it was BMW, got together and they're starting a new joint venture to connect their EV chargers with their with the local utility, so that cars can give energy back to the grid. And think about that. 3 automotive competitors came together to create that. So I think you're going to find that connection happening more and more. I'll give you another example. Black & Decker, I think a couple of years ago, came out with a energy management platform for their electric tools. That seemed to me to be a little bit of an overreach. So I think you're going to find, capitalism at work. You're going to find companies going out and doing this for their own benefit. So that connectivity will happen as long as there's some dollars in it. And I wouldn't ignore the complexity part. I mean, Victor, I think that you're kind of in the top 1% of people that ties all this stuff together. I think that it has to be as simple as possible. The complexity of a lot of the technology out there, and if we're talking about home automation, is too much.
And Andres, I'll put in a plug for a customer of ours, FPL, and their parent company, Nextera. I believe they rolled out a program which basically said, we'll come install a level 2 charger in your home, zero down, I don't know what it's $30, $40 a month or something like that. I think they're getting very close to what I would call an energy assurance program, which is basically, let me manage that, and then let me also manage your thermostat, if you will, for you, or your home energy manager for you. And we'll give you an assurance that your pricing, your spend on electricity per month will be optimal for you, because that is true customer service. And I think, being one of the most innovative companies I know, I think FPL and Nextera are already beginning to vector towards that. And that is the convergence I think, sir, you're seeking.
If I had $1 for every time I heard energy as a service, right? I mean, that's the big cat.
That's exactly where they're going. That's exactly where they're going.
Yeah. Okay. Other questions?
You guys spoke about security. Victor spoke about it's really unmanageable. So much IoT input. What happens if you get umpteen false positives? How do you begin to atone for them? How are you going to actually deal to get all these false positives?
Let me put my CSSP hat on.
You normalize that data with some type of application so that you know that it's a false positive. Because if you don't know it's a false positive, you have to treat it as something that could actually be interesting. So once you get that signature and find out what it is, then kind of done. Now there is a situation where every 1 out of 1,000 of those is something that you should have paid attention to. But you got to make that gamble because there's no way you're going to be seeing everything.
What's your dwell time? What's your dwell time?
The dwell time between, getting a signal ready.
Oh, I
This
can't answer
industry
that.
should not even know that.
I can't answer that.
You will not answer that. The other question would be about the algorithms. Gary was 100% correct. However, when you go through rinse and repeat on an algorithm, please know that 70% of it comes from open sources. Treat it, because most of your so-called those who come in and transform digitally are in the 20s. They do not know differently.
Okay, for anybody who's listening, the comment was that 70% of the algorithms are open source. And so when you're using any algorithm, you better make sure that you know what's in it. Yep. Okay. Any others? If not, we thank everybody. And I guess we have discussion on.
Don't go anywhere.